So moving on to what operations of functions are. So let's suppose f of x and g of x are any two functions. We can add, subtract, multiply, or divide f of x and g of x to form a new function which we'll call h of x. So if you have two separate functions, we can add these functions together, subtract these functions together, multiply or divide them to get a brand new function that we're going to call h of x. So let's look at a couple examples. If I'm looking at addition, okay, so my new function h of x is equal to my first function, which is f of x, plus my second function g of x. If my first function f of x is 2x and g of x is x plus 1, I'm going to fill these pieces of information for my two functions that are given here. So my new function h of x is equal to, and it's a good thing to start when you plug in your function to put parentheses around the entire thing, just so that you know what f of x, what that entire function is. So where I would have f of x, I'm going to plug in 2x plus, and in parentheses, I'm plugging in my whole gx, which is x plus 1. Since I'm adding across the board here, this is the same thing as 2x. I can drop my parentheses now because I don't have to distribute a negative. So I get 2x plus x plus 1, and 2x plus x is 3x plus 1. That can't simplify anymore, so that's my final answer. For the next one, subtraction, we're going to deal with this one the exact same way we did with addition. We're going to plug in what our function is equal to for both of these parts. So in this case, h of x is equal to my first function, 2x, minus, in parentheses, I'm going to plug in my whole g of x, which is x plus 1, equals, well now in this case, just like we talked about in the past, you have a negative out in front of this whole group. And when you have a negative out in front of the whole group, you have to distribute the negative to both of the parts in your parentheses for your second grouping. So if I rewrite this, I get 2x minus x minus 1, and 2x minus x is just x, or 1x, minus 1, and that's my final answer for the subtraction. I can't get any smaller than that. So that's my new function. The next one, multiplication, I'm going to kind of keep doing the same thing I did with addition and subtraction, same kind of form, except I'm going to be multiplying in between. So my new function, h of x, is equal to f of x in parentheses, so that's my 2x, times g of x, which is x plus 1. And now the parentheses in here, because I'm adding, I have an operation going on in here. I'm going to keep that in parentheses. I'm going to rewrite this one without your parentheses. And this is your distributive property, right? 2x times x is 2x squared, and 2x times positive 1 is plus 2x. And that's my answer for multiplication for this example. Last one, division. Division, my first function, f of x, is going on top as my numerator. My second one is g of x, which is going in the denominator. So my new function, h of x, is equal to 2x over x plus 1. Now you have to be a little bit careful here, because we know that if we have a fraction, my denominator can't be equal to 0. So the whole function, g of x, cannot be equal to 0. Well, since my whole g of x function is x plus 1, what would I have to plug in for x that would make this whole denominator equal to 0? Well, if I plug in 0, 0 plus 1 is 1, so that doesn't work. So if I go off to the right-hand side, if I take x plus 1 and I say it cannot equal 0, if I solve it the same way I would be solving if it was equal to 0, I know that x is not going to be able to equal negative 1. So 2x over x plus 1, where x cannot equal negative 1, because if x was equal to negative 1, I would have 0 in my denominator, and that would be undefined. So that this is the only value for x that I can't use in my domain. Therefore, talking a little bit about domain, the domain of H consists of the X values. Remember, domain is your X or your input. So all the values you can put into your new function H consist of the X values that are in the domains of both F and G. So if you have a domain and your domain works for F and it works for G, those two combined are going to also work for H, and we'll talk about that in a little bit. When H involves division, which is what we saw here in our fourth example, the domain does not include X values for which the denominator is equal to 0. And we talked a little bit about that here, but we're going to work on a couple more examples together to make sure that we understand this. So the next video we're going to talk about example 1.